So what exactly is I? Well, in math, I is what we call an imaginary number, right? I for imaginary is a good way to remember that. And I exactly is the square root of negative 1. So why is this imaginary? Why isn't it just like any other number? Well, the reason is the numbers that you're used to seeing are called real numbers, but I is in a different category, it's in a different plane, which we'll go into later. But examples of real numbers are like 1, 2, 3, 4.5, the square root of 12. Those are all regular positive numbers. But the reason I is so imaginary is this. Let's square it. Let's square the whole equation. Get this squared and this squared, right? So I squared equals negative 1. Now, this is a paradox, right? We can't have this happening because every integer that or thing that we're used to is going to be a positive number, right? The smallest square number we know is 0. 0 squared is 0. 1 squared is 1. Everything that's squared is positive. That's a general rule of thumb. But in this case, I is not like that, and it's special. So today we're going to be going over problems with I. Our problem is going to be find I to the power of 2018. Really, that could be any number, but I picked 2018 because it's the current year, and it's also a nice number to experiment with, especially in terms of I. So let's get started. We're obviously not going to multiply out I 2018 times to get our answer, but we'll just start our way and see if we can find any patterns. So I to the first is going to be just I, which is the square root of negative 1, as we defined it. Now I squared is going to be I times I, which is the square root of negative 1 times the square root of negative 1, which is the same thing as just squaring squaring the square root of negative 1, making it negative 1. I cubed is going to be I squared times I. Now we've already got I squared, which is negative 1, so we're going to bring this down. It becomes negative 1 times I, which is negative I, or the negative square root of negative 1. Remember, you can't just bring this negative in, so we'll keep it outside. Now I to the fourth is going to be I cubed times I. We're going to bring down the I cubed, the negative square root of negative 1, the whole thing, times I, which is basically negative I squared, right, because this is the same thing as I. So negative I times I is negative I squared, which is going to be just 1, right, because I squared was negative 1. And now we're on to I to the fifth, which is I to the fourth times I equals, which is just I to the fourth is 1. We'll bring it down, and that becomes I. Now we can see that we've actually finished our pattern here, because this was also I on the very first one. So our prediction is that the cycle goes I, and then when you multiply that by I, it becomes negative 1, which becomes negative I, and then it becomes 1. Let's erase all this, and we'll test if that's true. So our prediction for the next one should continue in the same cycle, right? So we've gotten to I to the fifth already. So the first one, I was I to the first, I squared was negative 1, I cubed was negative I to the fourth was 1. So if we continue on our cycle, I to the fifth is I, as we got, so I to the sixth should be negative 1. Let's test if that's true. I to the sixth, which is just I cubed times I cubed. And we had I cubed as negative I, so that's negative I times negative I, which is the same thing as I squared, and I squared is going to be right here, which is negative 1. So our prediction was correct, right? So now let's try to use our cycle, our little handy formula. So now we can use this for every I problem that we have from now on. So the rule of thumb we have here is that the first one is going to be just I. The second one is going to be I squared, or -1. The third one is -I, and the fourth one is just 1. I'll make these ones clearer so you can tell them apart from the I. Okay, so how are we going to use this to solve I to the 2018th? Our little cycle here means that every 4 is going to be 1. So the 4th one, the 8th one, the 12th one, the 16th, all the way up to any multiple of 4. So if it's I to a multiple of 4, it's going to be 1. We can use this rule to find out what I to the 2018 is by bringing this down to a smaller case. So let's pretend that our number is not 2018. We'll pretend it's a smaller number. Say something like I to the 13th. So if we can find the closest multiple of 4 to 13, which in this case we know is 12, and then we calculate the remainder from there, we can find what that number is in our sequence. Because if we have a multiple of 4, we're at this number in our sequence, the remainder will start from here, number 1, and then it will be number 2, number 3. So these are all, if the remainder is 1, it'd be right here, remainder is 2, and if the remainder was 3, it'd be right there, and if the remainder was 4, it'd be just divisible by 4, right? So it'd be this one right here in our sequence. Let's go through this. So 13 divided by 4 will be 3 with a remainder of 1. And since we see the remainder of 1, we see it's the first number in our sequence, which is just I. So I to the 13th would be equal to I. Okay, so now let's bring this back up to the I to the 2018. Also, if you didn't understand that, that's okay. Just leave me a comment. I'll try to explain better. Or you can just rewatch the video and maybe it'll make more sense. So let's continue with this. I to the 2018. We'll divide that by 4 to find the remainder, right? So 2018 divided by 4. I'll let you do the math yourself, but that's a remainder of 2 because it's 2016 is the closest multiple of 4. I'll go over divisibility rules later, and that should help with this. It'll make things like this a lot easier. Anyway, so if it's 2, that means our second number in our sequence is going to be our answer. So our sequence was I, then I squared is -1, so -1 is our answer. I to the 2018th power is -1. And we've solved it. So to summarize all this up, I to the power of a number, let's say n, is the same thing as I to the power of the remainder when n is divided by 4, the remainder of n divided by 4. Thanks for watching.